Hi everybody, this is Math 025, Module 4, Part 2, and this is Applications of Rational Equations. It's our last video for this class and for Module 4. And here we're going to look at some real-world applications of rational equations. We're going to start off first with just some problems that are written in words. So, and sometimes you'll see this written out and you need to know how to translate it into an equation. It's not always the easiest until you get some practice in. So here we have the quotient of a number and 3 minus 1 equals 5/4. So, when I'm going to write this, I know that I have the equal sign there. So it equals 5/4. And then the quotient of a number and 3. Remember, quotient means division. So that means a number and 3. So it's going to be x divided by 3 minus 1 equals 5/4. So now we've created the equation and we have to find the number. So we want to get rid of our fractions. So we want to multiply everything by our common denominator. And if we have 3 and 4 as a denominator, we're going to use 12. So we'll multiply everything by 12, or 12 over 1. So if I do my work over here, 12 over 1 times x over 3. 3 goes into 12 4 times, so it gives me 4 times x, or 4x. So I have 4x, and then 12 times negative 1 is minus 12, equals, and then we have 5/4 times 12 over 1. 4 goes into 12 3 times. 5 times 3 is 15. So we have our equation 4x minus 12 equals 15. And it's a linear equation, so to solve it, I'll isolate x by adding 12 to both sides. And that will give me 4x. Oops. 4x is equal to 27. Divide both sides by 4. So x is going to equal 27 over 4 for our final answer. All right, so our next equation is twice the reciprocal of a number minus 5 is the same as 3/7. So it's the same as, I know it's going to equal 3/7, and it's twice the reciprocal of a number minus 5. So that twice means we're going to have that 2 on the outside. The reciprocal of a number, so if my number, we don't know what it is x, the reciprocal is going to be 1 over x. So we'll have 1 over x minus 5, and twice that is equal to 3/7. So we are going to clear our equation of fractions. First, I am going to distribute that 2. So that will give me 2 over x minus 10 is equal to 3/7. And then my common denominator here will be, we have x and 7, so 7x. So when we do the math, if I have 7x over 1 times 2 over x, my x's cancel out, and 7 times 2 is 14. So that'll give me 14 minus 7x times 10 becomes 70x equals, and then we have, 3/7 times 7x over 1. My 7's cancel, and it leaves me with 3x. So what I want to do here is we will start by, I'm going to add 70x to both sides. So now we have 14 is equal to 73x. Divide both sides by 73. And x is going to equal 14 over 73. Kind of a crazy answer, but it works. All right, so next we're going to look at similar triangles. And similar triangles are two triangles that have all angles that are equal, equal, and their corresponding sides are always proportional. So they're the same triangle. The angles are the same, but the sides are proportional to each other, corresponding sides. So to find a missing side, you're going to set up a proportion and solve it. So we're going to start off and we are going to look at a proportion where I know both measurements. So here, like I know these sides are corresponding. They look to be the shortest sides on both. I can tell by measurements. And so I know that they're proportional. So I can make it 20 over 8 is equal to, now I need to find this long side here. The 60 goes with the 20. It's on the same triangle, so I'm going to put it on the top and my x on the bottom. And then we would just cross multiply to solve. So 8 times 60 is 480 is equal to 20x. So we're just solving that proportion like we would normally. Divide everything by 20, and I get x is going to equal 24 centimeters. Okay, so here again, we're looking at two similar triangles and we want to find y. So again, the first thing you want to look for is a pair of corresponding sides where you know both measures. And we happen to have two here. We have 431 matches up with the 237, or the 132 matches up to the 72.6. They both have some decimals in there. It doesn't matter what we use. I'm going to go with the 132 over 72.6. And that will be equal to, the y is with the 132, so it'll be y, and that corresponds to the 276.1. So again, we'll cross multiply like a proportion. It's solved in proportion. So it'll be 72.6y is equal to, when I multiply, I end up with, let's see here, 132 times 276.1, 36,445.2. Then we'll divide everything by 72.6. And that gives me y is equal to 502, and it would be inches. So 502 inches. So the next couple problems that we're going to go through are going to be work rate problems. And here we're going to look at things where it takes somebody a certain amount of time to do something, someone else a certain amount of time, and how long would it take if they work together. So here we have Bill and James, and they are solving a 1,000-piece puzzle. Bill can solve the puzzle in 5 hours. So I know it takes Bill 5 hours. And it takes James 3 hours. How long will they take if they work together? So together, we don't know how long it is, but we know it will take X hours. Give the answer in both hours and minutes. So to solve this, we have 5 hours, we have 3 hours, and X hours. What we really want to do is we want to look at this as the time per hour. So it takes Bill a total amount of 5 hours, but how long or how much of the puzzle can they do per hour? And if it takes Bill 5 hours to solve one puzzle, per hour he can do 1/5 of the puzzle. James, if it takes him 3 hours to work on the whole puzzle, per hour he can do 1/3 of the puzzle. And together, if it takes them X hours, they can do 1/x of the puzzle. So this right here is actually going to be our equation. We are going to have 1/5 plus 1/3 equals 1/x. And we'll use this to find out how long it'll take them to work together. So we've broken it up into an equal time frame. We've looked at it per hour. We'll get rid of our fractions by multiplying by a common denominator. And our common denominator is going to be 15x, because that works for 5, 3, and x. And so if I multiply 15x over 1 times 1/5, 5 goes into 15 3 times, so it becomes 3x, plus, if I do 15x over 1 times 1/3, 3 goes into 15 5 times, so it becomes 5x. And then over here, my x's will cancel, leaving me with 15. So combine like terms and solve. So 3x plus 5x will give me 8x equals 15, and then we'll divide by 8. So right now I have x equals 15 over 8 hours, but they want hours and minutes. So let's start by turning this into a mixed number. I know that 8 will go into 15 one whole time, and then there will be 7 left over. So it would be 1 7/8, or that's 1 hour. And then to figure out what 7/8 is of an hour, we're going to multiply that times 60 over 1, because there's 60 minutes in an hour. So if I do that, 7 times 60 divided by 8 is going to give me 52.5. So our answer is, I'm going to put it in blue here, 1 hour and 52.5 minutes. And that will give us our final answer there. And again, I just took the fraction of the minutes, the 7/8, and times it by 60, because there's 60 minutes in 1 hour, just to figure out how many minutes there were. All right, so we have another work problem here, and this time Mandy is a licensed dog groomer, and Sarah is a dog groomer in training. Mandy can groom a golden retriever in 45 minutes, while Sarah can groom the same dog in 1 hour. How long will it take if they work together? So here, we're looking at the amount of time per hour. So Mandy can groom a dog, and we want to write it in terms of hours. So we know Mandy, she takes 45 minutes, and Sarah takes 1 hour. But I want per hour, so we want to figure out together is x. So Mandy, if we're converting that to hours, it's already less than an hour. So I know that it's 45 over 60, because that's 60 minutes in an hour. And then if I simplify that, it's going to simplify to 3/4 of an hour. So we can divide them both by 15. So per hour, let's do this, per hour, Mandy can do, it takes her 3/4 of an hour. She can do 3/4 of the dog, or it takes her 3/4 of an hour to trim the dog. And then Mandy, or Sarah, takes exactly 1 hour. So per hour, 3/4 of an hour it takes Sarah to do the dog, and then Mandy can complete the dog in 1 hour. Together, they will still be 1 over x. So we set up our equation. It's going to be 1 plus our 3/4, or 3/4 plus 1 equals 1 over x. We want to get rid of our denominators, so my LCD is going to be 4x. So if we distribute here, 4x times 1 gives me 4x. Then 4x over 1 times 3 over 4. My 4's cancel out, and it gives me 3x here. And then equals, my x's cancel out, so it equals a 4. So 4x plus 3x will make it 7x equals 4, and we'll divide by 7. So x equals 4/7 of an hour. But again, I want that in minutes. So I'm going to take my 4/7 and times that by 60 minutes per hour. So if I do 4 times 60 divided by 7, it is going to be a decimal. So it's approximately 34.3 minutes. Or you could just say about 34 minutes if you round to the nearest minute. So about 34 minutes to complete grooming the dog. Okay, so now we have a car that travels 90 miles in the same time that a truck travels 60 miles. The car's speed is 10 miles faster than the truck's, and both move at a constant rate. Find the speed of the car and the speed of the truck. Use the distance equals rate times time formula, and also find out how long it took to travel the distances. So, information that I know here, my car. All right, I know it travels 90 miles. Okay, and that is my distance. Okay, the rate, I don't know, but I do know the car's speed is 10 miles faster than the truck's. So, our rate, 10 miles faster than the truck's. Well, I don't know the truck's speed either, but I'm going to say x plus 10 for the car. And my time, we don't know. But we do know that it is the same as the truck. So they're traveling the same amount of time. Then we have the truck. It travels 60 miles. So again, that's our distance. Our rate is x, and the time, again, we don't know how long, but we know it's the same as the car. So what we're going to do here is we know the distance and the rate, but we're looking for the time. And we're also looking for the speed we saw for x. Instead of working with our formula distance equals rate times time, let's solve our formulas to find the time, because we know the time is the same for both. So if I do that, I'm going to divide both sides by r. So we're going to deal with distance divided by rate equals time. And again, I know the time is the same for both the car and the truck. So for the car, if I were to write out my formula, I would have distance of 90 over x plus 10 is equal to time. And the truck would be 60 over x is equal to time. They're both equal to t. The time is the same. So to solve this problem, we're going to set both equations equal to each other. So we will have 90 over x plus 10 is equal to 60 over x. We will cross multiply because it's like a proportion. So I end up with 90x is equal to 60 times x plus 10. When I distribute, it gives me 90x equals 60x plus 600. I'm going to subtract 60x from both sides. So I end up with 30x equals 600 divided by 30. And x is going to equal 20. And that x is going to represent 20 is our rate, and that is the rate of the truck. So they're going 20 miles per hour, and the car is doing 20 plus 10, or 30 miles per hour. Now they also wanted to know the time. So if I know that the distance divided by the rate equals the time, 60 divided by 20 will give me 3 hours that the truck was traveling, and 90 divided by 30 will also give me 3 hours. So both cars were traveling for 3 hours, and their rates were 20 miles an hour for the truck and 30 miles an hour for the car. Okay, so this last problem is similar to the one we just did with the car and the truck, but now we're talking about the same truck. And for this one, I know that the truck it travels 300 miles through flatland. So we're going to talk about the flatland, and the distance is 300 miles. And it can travel the 300 miles in flatland in the same amount of time that it takes to travel 180 miles through a mountain area. The rate of the truck is 20 miles per hour slower in the mountain area than in the flatland. Find the rate of the flatland and the mountain area. Also find how long it took to travel through the areas. So the rate, I don't know right now, but it's going to be X. And then in the mountain areas, the distance the truck traveled was 180 miles. And the rate, it's 20 miles slower than the flatland. So X minus 20 is our rate. And we know the time is the same for both. So again, if we have our distance equals rate times time, to solve this, we're going to divide both by the rate. So we have distance divided by rate equals time. And we're going to set our two equations equal to each other again because the time is the same. So we're going to do 300 over X is equal to 180 over X minus 20. Again, it's like a proportion, two ratios equal to each other, so we're going to cross multiply. We're going to have 180x equals 300 times x minus 20. So it gives me 180x equals 300x minus 300 times 20 will give me 6,000. And let's see here, I'm going to subtract 180x from both sides. And we're going to end up with 0 equals 120x minus 6,000. So we'll add 6,000 to both sides. So 6,000 equals 120x. Divide both sides by 120. 6,000 divided by 120 is going to equal 50. So x equals 50, which is our flatland speed. So it's 50 miles per hour. The mountain area is 20 miles slower. So 50 minus 20 is going to give me 30 miles per hour. And then we need to figure out how long it took them. So I can take the 300 divided by the rate of 50. So 300 divided by 50 is going to give me 6 or 6 hours, which if you do 180 divided by 30, you should also end up with 6 hours, because remember the time was the same. So they both were traveling for 6 hours. Over the flatland, the truck could go 50 miles an hour. Over the mountain area, it could go 30 miles per hour. And that is it for our last video for the last module for Math 025.